Today's forecast. A high wind warning is in effect. Monster winds are predicted blowing in from the east at 900 miles per hour. Gusts could be even higher. Luckily, this isn't the weather for your town. It's the forecast for the planet Neptune.
The fastest winds on Neptune, if they were on Earth here, would be supersonic.
What would happen if winds that fast blew on Earth? Could anyone survive?
It's going to literally blow you away.
It's the fastest winds in the solar system on Deadliest Space Weather. Earth's is just one kind of weather. On other planets, there are storms beyond the imagination, climates and conditions that we hope to never see on Earth. But could they happen here? And if so, could we survive? Deadliest Space Weather. Washington, D.C. A calm day suddenly turns violent as the fastest winds in the solar system touch down in our nation's capital. They're clocked at 900 miles per hour.
The fastest wind ever recorded on Earth was about 300 miles an hour. And more typically, the very fast winds are, say, 200 or below. So 900 is quite a remarkable number.
You would think that 900-mile-an-hour winds would be like a shockwave.
The destructive shockwave and wind of a nuclear bomb may travel as fast. But the winds on this frightening day are different because they keep coming.
900 miles an hour is supersonic, so there would be no warning in the White House. At 900 miles an hour, the windows immediately blow out. The inside of the White House increases in pressure, sort of like a balloon. The roof would immediately be blown away, explosively blown away. And the walls would then fail fairly quickly.
Winds like this really do howl on other planets. And the fastest winds in our solar system are found on Neptune, the 8th planet and farthest planet from the Sun, orbiting 30 times farther away than the Earth, 2.8 billion miles. Unlike the gas giants Jupiter and Saturn, Neptune is an ice giant, a ball of water, ammonia and methane ices with a small rocky core and a gaseous atmosphere. A Neptune day, the time it takes to rotate once is about 17 Earth hours, and its trip around the Sun takes 165 Earth years.
When you look at Neptune for the first time, you see that it's blue, gorgeous blue. And so we think that the atmosphere of Neptune is mainly hydrogen with a little bit of helium and some impurities like methane gas. So Neptune is minus 330 degrees, very cold because it's so far from the Sun, the windiest planet in the solar system, but it's a gorgeous blue color because of methane.
In 1989, the Voyager 2 space probe flew by the icy giant, giving us mankind's first close-up of the blue planet. The winds Voyager detected there amazed everyone. How can an Earthling even begin to experience the feel of the monstrous rush of 900-mile-per-hour winds streaming around the planet Neptune? At Vegas Indoor Skydiving off the Las Vegas Strip, a giant aircraft propeller mounted below the floor generates winds fast enough to lift you off the ground. Planetary scientist Adam Showman studies the fastest winds in the solar system, and he's come here to experience some of the fastest winds on Earth.
This will be about the fastest speed I can experience without seriously risking my life. The wind speed they're going to subject me to is about 120 miles an hour. This is what we call terminal velocity. That's when the resistance due to the force of the friction on me falling through the air equals out with the gravitational force pulling down on me. Let's do this.
even under controlled conditions, winds this fast are dangerous. Adam is required to wear a protective suit, a helmet, and goggles. Although they are strong enough to suspend a fully grown person in midair, these winds are still far slower than those that whip around on Neptune.
You're not going to encounter a 900-mile-an-hour wind on the Earth. In fact, you're not going to encounter even a 100-mile-an-hour wind unless you're in the right place at the right time, specifically in the center of a hurricane or a tornado.
The record for the world's fastest wind was set by Tropical Cyclone Olivia in 1996, with gusts in Australia clocking in at 253 miles per hour. In the Northern Hemisphere, the record holder is windy Mount Washington in New Hampshire, where a spring storm in 1934 strafed the peak with winds at 231 miles per hour. But those records are for non-tornado winds, because weathercasters put tornadoes in a different category. In 2011, a tornado ripped through Joplin, Missouri, a small city of 50,000.
Oh my gosh, this is awful.
Wind speeds couldn't be measured with the available instruments, but by the damage they caused, they couldn't have been less than 200 miles per hour. In its wake, as many as 160 people were dead and more than 1,000 injured. Damage was estimated at over $2 billion. But the highest wind ever measured on Earth came from the 1989 tornado in Moore, Oklahoma. While other winds are physically measured directly with anemometers, tornado speeds are estimated with Doppler radar. A mobile Doppler unit estimated the Moore tornado winds at between 281 and 321 miles per hour. As much as 200 miles per hour faster than the winds in the vertical wind tunnel.
I've just experienced winds of 120 miles an hour. The fastest winds on the Earth are almost 3 times that fast. And the fastest winds on Neptune are 7.5 times that fast.
But at 900 miles per hour, winds in the thin upper atmosphere of Neptune may not seem to be as fast as they are.
What a 900-mile-an-hour wind would feel like would depend on where you are in the atmosphere. If you're at very high altitude, the density is low, and it's not going to feel like much. There's just not much force there. On the other hand, if you feel a 900-mile-an-hour wind down deep in the atmosphere, it's going to literally blow you away.
At a mile deep into Neptune's atmosphere, the density is about what we'd feel on the surface of the Earth. At 900 miles per hour, these winds on Neptune are not only constant, but they have probably been blowing for millions, perhaps billions of years. If sustained winds that fast struck here on Earth, could even our longest-lasting monuments survive? The 900-mile-an-hour winds around Neptune's equator are the fastest in the solar system. On Earth, our fastest winds are a destructive force. We experience them as hurricanes or tornadoes and are staggered by the damage they leave in their wakes. But Neptune's fastest winds are constant and have probably been blowing at their high speeds for millions or billions of years. Imagine a never-ending stream of wind like that on Earth, where some of mankind's oldest structures stand.
The Great Pyramid of Giza has withstood the winds and sand of its location for about 4,500 years. How long would it take the winds of Neptune to erode them? Well, a sandblasting nozzle erodes limestone at about 1/16 of an inch per hour, maybe a little less. And the nozzle pushes sand or beads out at that limestone at about 200 miles an hour. Winds at 900 miles an hour have 20 times more energy. 20 times more energy means an erosion rate of roughly an inch an hour. At 900 miles per hour, it would take only 3 or 4 years to erode the Great Pyramid of Giza into dust.
The fast winds on Neptune are not the icy giant's only extreme weather. The distant planet turns out to be a stormy one.
When Voyager 2 sailed past Neptune for the first time in history, we had close-up shots of Neptune, and we were shocked. Shocked to find that there was a dark spot on the surface of Neptune. And it seemed to be stable, and it seemed to be very much like the red spot of Jupiter.
The Great Dark Spot of Neptune was an oval-shaped storm circulating every 16 days and covering an area as big as Earth. Astronomers wondered if it could be as long-lasting as Jupiter's Great Red Spot, which is at least 350 years old. Voyager's discovery was unexpected because before the flyby, all astronomers could see of Neptune from Earth telescopes was a plain blue blob.
We found lots of other surprises on Neptune. For example, there were the scooter clouds, a compact group of white wispy clouds that was moving to the east much faster than the Great Dark Spot. In addition, there was a smaller dark spot, often called Dark Spot 2 or even the Wizard's Eye.
Voyager's spectacular flyby of Neptune may have been shocking, but it was not the end of the story.
The Hubble Space Telescope gave us another shock. We have a more recent picture of Neptune, and hey, what happened to the dark spot? It's gone. So we now realize that these spots come and go. They can shoot across the surface of planets, and they're not necessarily stable. We think because of chaos theory that eventually a new spot will occur, but right now, as taken by the Hubble Space Telescope, there's no dark spot.
The most recent pictures of Neptune now show a planet with remarkably turbulent weather, seasons that are many decades long, and new storms swirling where earlier storms disappeared. And the biggest mystery behind Neptune's wild weather is what powers it. Winds anywhere are driven by heat, and Neptune is very cold. The sunlight it receives is 900 times weaker than we get on Earth. How then could it possibly have the fastest winds in the solar system? Planet Earth and planet Neptune are about as different as planets can be. But they do have one thing in common. Each has a fairly steady wind blowing around its equator. Except that on Earth, where they're called the trade winds, they blow at about 12 miles per hour. On Neptune, they scream at 900. What powers the hyper winds of Neptune? Earth's winds are powered by heat from the sun, but our planet receives 900 times more sunlight than Neptune.
If you think sun powers weather, well, you're all wrong, because Neptune has nothing to do with the sun powering the weather. So something else powers the weather and the winds on Neptune.
That something else may be hellish heat from deep within the planet. While Neptune's atmospheric temperature is 330 degrees below zero, its core may reach 12,000 degrees above, and that stirs things up.
Just like when you boil water on a stove, that water gets heated from below, creating convective currents. You watch the water bubble. Same thing is happening on Neptune.
The upward bubbling of gas from the deep interior joins the fast rotation of the planet to generate high-speed wind.
Usually winds are created because I have hot and cold next to each other. And so the movement of air is the movement of hot air to cold areas. However, you can also have winds driven by the rotational rate of the planet itself. And that's one of the contributing factors to the fact that Neptune is the windiest planet in the solar system, because it's rotating rapidly.
Add Neptune's fast rotation to its size, and the speed adds up. The big planet is nearly 100,000 miles around the equator, almost 4 times the size of Earth. Rotating once every 17 hours, its equatorial speed reaches 6,000 miles per hour. Points on Earth's equator are moving at only 1,040 miles per hour. If Neptune-scale winds blew on Earth, an airliner flying from Los Angeles to New York would face 900-mile-per-hour headwinds. Commercial jets fly at around 600 miles per hour, so this one would actually be pushed backwards. It would be faster to take the long way around, turning the headwinds into tailwinds, and getting to New York in 13 hours at an effective speed of 1,700 miles per hour. Neptune's winds not only blow fastest in the solar system, they also blow backwards, opposite to the direction of the planet's rotation. It's the product of something familiar to all weathercasters, the Coriolis effect. As a planet rotates, it makes things travel along curved paths. A rotating table in a lab at UCLA shows how it works. A camera mounted up top rotates along with the table. So from its position, the table appears perfectly still.
So what we do to show this is we launch a little ball, actually a little ball bearing, from the rim of a rotating table towards its center. So as it moves inward, it actually appears to get deflected off to the side when viewed in the rotating frame. And that's the deflection that is often referred to as Coriolis deflection.
On the rotating table, the ball veers to the right, opposite to the table's rotation. On Neptune, its winds work in a similar way, blowing from east to west, while the planet rotates the other way. In fact, the same idea governs Earth's trade winds, which also flow from east to west, opposite to the way our planet rotates. On Earth, the winds flow only in the thin envelope of our atmosphere. On Neptune, they begin deep within the planet, giving them thousands of miles to build up speed as they first rise and then curve around the surface due to the Coriolis effect.
Winds on Neptune are actually more like Earth's winds than any of the other giant planets. The winds on Neptune are just a lot faster than they are here on Earth.
The winds of Neptune are the fastest in our solar system, but they may seem like a gentle breeze next to planets around distant stars, with winds up to 9,000 miles per hour. The deadliest space weather in the solar system has no rivals when it comes to the blistering 900-mile-per-hour winds on Neptune. But elsewhere in the universe, there are planets with winds 10 times as fast. They are giant planets, like our own Jupiter, balls of gas and liquid with no solid surface to hold winds back.
On a planet that doesn't have a solid surface, once you're able to spin up winds to a very fast speed, it becomes relatively easier to sustain those winds because there's not a lot of drag or friction that's holding these winds back, like on a planet like the Earth.
One such planet has been found 51 light-years away from Earth. It orbits so close that one side of the planet always faces its sun and the other faces away. That would mean one side is searingly hot and the other side is incredibly cold. But the Spitzer Space Telescope showed that the hot giant measures a consistent 1,700 degrees on both the day side and the night side. For that to happen, fast winds must be transporting heat around the planet. How fast? Calculations figure them at up to 9,000 miles per hour. By contrast, the 900-mile-an-hour winds on Neptune seem almost manageable, something we might actually deal with on a human scale. If Neptune's 900-mile-an-hour winds were to blow on Earth, scientists might think of harnessing them for energy. On Earth, wind turbines are designed for speeds up to 200 miles per hour. When wind gets too high, the turbines are turned off to avoid damage. But how much damage could they avoid in Neptune-style winds at 900 miles per hour?
If you had air much the same as we have here on the surface of the Earth, that type of atmospheric pressure, the turbine would rip apart very quickly. It would become unstable, the wind blade would fly apart.
But mankind could hardly expect its structures to withstand Neptune-speed winds. At 900 miles per hour, most buildings would blow away. Humanity's durable monuments would erode into nothingness, as the deadliest space weather proves too much for the Earth. But nearly 3 billion miles from the sun, Neptune shines. Its eerie blue disguising the tempestuous weather we've only recently come to know. Weather driven with awesome power by the fastest winds in the solar system.